Hello, this is section 3.7. This section is about elasticity of demand. All right, so before we talk about the elasticity of demand, first we need to know about uh, the relative rate of change of a function. Let's say a function, let's say f of x. Okay, so the definition of this one, or the equation, or whatever you want to say, basically the relative rate of change of a certain function is always the derivative, or the first derivative, or the derivative of the function. So we have f of x, right? So we're going to take the derivative of that function, divide by the same function. Right? Or we can also write this is same as d over dx, or the derivative of natural log of f of x. All right, so these two are equal. Why? Because let's see, well, if I take the derivative of this function, natural log of f of x, I will get this thing. So if I take the derivative of natural log of f of x, so the derivative of natural log is 1 over, well, whatever is there. So since we have f of x, so 1 over f of x. All right, so that's the derivative of natural log. And also we have to take the derivative of this inside f of x function, which will be just the derivative, or f prime of x. So see, these two are same thing, right? So here basically I'm just going the opposite way. All right, so this, most of the time we write from this point to this point, but well, we know this, so if we have this, we can also say this. So I'm just going opposite way. All right, so let me just erase this, we don't need that. Okay, so now so we can say we can take this as the definition of relative change, relative rate of change of any function. All right, so now let's see elasticity. Elasticity. Elasticity of demand at price. Let's say P. All right, so the elasticity of demand at price P. So here, what we can say is that, let's draw a graph. So elasticity here, we can basically, well, the elasticity here means, this means the elasticity means it is a slope. The slope that depends on demand and price. All right. So what we're gonna do here with this graph is, we're gonna say this x-axis graph is the price, or let's say price is P, and this y-axis is demand. All right, so the demand will depend on the price, right? So when you see the market, well, if you see any items which is in cheaper price, you will see high demand. If the price is very high, then the demand will be low. So right, so yeah, so the demand is a dependent variable, price is independent variable. All right, so let's say now this is any function f that depends on P. All right, and let's draw a line something like this. This line is the elasticity or the slope. So basically, if you want to find the slope of this line, um, is change in y over change in x, right? But since if you see this line, when you go from left to right, it's decreasing, right? So if a line is decreasing, when you go from left to right, the slope is always going to be negative. So it has to be some negative number. All right, so if the line is increasing from left to right, then that will be positive. But since we see a line is decreasing, we can automatically think that, okay, the slope is negative, some negative number. All right, so when we say slope, it is this. But since we have elasticity here, that depends on demand and price. So the elasticity here will be, well, elasticity, we can also say elasticity is E, that depends on price. All right, so elasticity, let me write it on a new page. I don't think I have enough space here. So elasticity EP is equals to, now here, since we're talking about the relative rate of change, so we will define the elasticity of demand with using this idea. Okay, so what we're going to say, elasticity or EFP is relative rate of change of demand, relative rate of change of demand, or demand, we say F of P, right? We said that here. Demand, we say F of P. Okay, and divide this by same thing, relative rate of change of price. So we say price is P, right? We say demand is F of P. We said price is P. And again, since we said the slope is negative, since it is, the line is decreasing, so we have to say the same thing here. It's negative. Okay, so now after this, we define the relative rate of change of anything is this one, right? Take the derivative of whatever is there and divide by the same thing, or we simply say take the derivative of natural log of whatever function is there. All right, take the derivative of the natural log of whatever function is there. So here, now what we're going to say is that since we have a relative rate of change of f of p, so this also means d over d, what we're going to have here. Since here we have f of x, that's why we take the derivative in terms of x. So that's why I have a dx here. But here, since we have p here, so we're going to take the derivative in terms of p. So negative d over dp, and take the derivative of this. I'll take the derivative of natural log of f of p. All right, so the relative rate of change of demand is this. All I'm doing here is I'm just using this formula. Okay, And again, divide this by relative rate of change of price, d over dp of natural log of, now I have p here, so that's why natural log of p. Okay, now okay, so now what we're going to do here is I have to take, well, there is a negative there still, right? So we have to write that negative. And when I take the derivative of this natural log of f of p, then the first one, it will be 1 over f of p, right? And then take the derivative of this inside part using general, which will be times f prime of p, divide by, now take the derivative of this natural log of p, which is basically, since we are taking the derivative of natural log of p in terms of p, right, in terms of p, so it will be just 1 over p, right? So now after this, I get this from the numerator, I get f prime of p over fp, and then, well, we are dividing this whole thing by 1 over p, so if I change, well, basically I can move this p to the numerator, so I can just write this whole thing by multiplied by p, right? So this is just an algebra. So what we can say is elasticity of demand, or EP. So we said this is elasticity, right? Elasticity. Elasticity of demand at price P is, well, the formula is this. Okay, so now using this formula, let's do an example. Let's do one example. So, okay, suppose the price P and demand, we said demand is f of P, right? But let's write something else. Instead of writing f of P, let's just write x. All right, it's just a variable, so I'm just saying x of specific product are related by a certain function. Let's say a function is x is equals to 25,000 minus 500 times P, or 500 times price. So as I said that the demand is x, or we can also say that x is same as, because this x is same as f of P, right? Because we said the demand, we can also write demand as f of P, because the demand depends on the price. All right. So now after this, we need to find the elasticity of demand. Okay. Or simply we can say EFP. And also, after we find EFP, we should also find, let's say, EF10. All right, so we need to find these two, all right? Okay, so now let's start this. So as we know that the elasticity formula is that we derived from here is this one, right? So we know that. So what we can say here is the elasticity. Let me just write that here again. Negative P times F prime of P over just F of P, right? So now, well, if you see this one, we have F of P, right? Because this whole function is F of P, but we don't know F prime of P, but we can find F prime of P uh, from here, right? So well, F prime of P, or the derivative of F of P is, well, first I have to take the derivative of this 25,000. Well, this is a number, so that will be 0 minus, so the derivative of 500p is, well, 500 will stay there. So minus 500 will stay there. And the derivative of p in terms of p is just 1, right? So we don't have to write that. So it's just negative 500. So now let's just plug this in here. So now p sub p is equals to negative p. So derivative of f of p is negative 500 times negative 500 divided by f of p is 2500 minus 500p, right? So now after this, on the numerator, it will be negative times negative, that will be positive. So 500p over, so here, since we have to write our answer in a simplified version, so what we can do is we can factor out something from these two. So we have 25,500. So it looks like I can factor out, I can factor out 500. So if I factor out 500, then the remaining terms will be 50 minus p. All right, so you can see of so 500 times 50 is 25,000, and 500 times negative p is negative 500p. Right, so yeah, these two are same thing. Okay, so now it looks like I can cancel this 500, 500, saying our simplified answer is, or the E sub P, or elasticity of the demand, is P over 50 minus P. Okay, so that's what we are looking for, and we got that, right? Now the second one is, well, it's easy, right? So once you get E sub P, we just have to plug in this 10 here. So that will give 10 over 50 minus p is, or 50 minus 10 is 40, which is also 1 over 4. All right, so here, yeah, simple idea. Here we didn't do anything new. It's just that we introduced some new concepts or some new definition. All right, so you just need to know these idea and also the formula. Okay, so yeah, please review these things, and you will see similar problem like this on the homework as well. All right, so yeah, that's it for this section. And like I said, for the exam, for this exam 2, I think I've covered everything that I want to cover for exam 2. So the exam 2 will be over 3.2 to 3.7. All right, 6 and 3.2 to 3.7. So this time, your exam, well, I'll talk more about the exam later on, but I'll just give you a brief idea. So the exam will be, well, if you saw the exam one, well, exam one was quite similar to the review, right? The review I gave you. So I'll do the same thing, but not exactly like exam one. So this time your exam will be a little bit similar to the review, and also I'll ask something from um, from the lecture. So that means I'll ask the ideas that I talked in the lecture, and also it will be similar to the examples. So basically, I'll be focusing more on the ideas or concepts. All right. All right. So I will ask few problems related to the concepts as well. All right. So that's why I'm telling you guys, please watch my lecture videos and ask me questions. So that's why I have an office hour. All right. So anyway, so yeah, that's it for this lecture. I'll see you in the next video. Thank you.